All right, today we're looking at the 2015 Calculus BC exam. This is question number 6. I classify it as a type 10 problem. By the way, you can check out playlists in the link in the description below to see all the different types. Type 10 is sequences and series. So here we go. The Maclaurin series, which is a Taylor series centered at 0, for the function f is given by, and then they write out the first 1, 2, 3 terms and the general term. And it converges to f of x for all absolute value of x less than r, where r is the radius of convergence. Use the ratio test to find r. So what we have is we have a series that is centered at 0, and we are determining how far away from 0 is this series going to have convergence. And the ratio test, for those who need a little refresher, says that if the limit as n goes to infinity of the n plus 1th term over the nth term is less than 1, then we have convergence. So this is what we're going to do. We're going to execute the ratio test on this rule here. So the limit as n goes to infinity of the n plus 1th term would be -3 to the n plus 1 minus 1 over n plus 1 times x to the n plus 1. So there's our n plus 1 term. To divide by the nth term is the same as multiplying by the reciprocal of the nth term. So we're going to multiply by the reciprocal of the nth term, which means we have n on top, x to the n on bottom, and -3 to the n minus 1 on bottom. So this is our n plus 1th term divided by our nth term, or multiplied by the reciprocal. As we start to clean things up in this expression, the plus 1 minus 1 cancels out, and we have an n on top and an n minus 1 on bottom. This leaves us with just a -3 on top for that piece. The x to the n plus 1 over x to the n, the x to the n's cancel, and we're left with an x on top. And then the n over the n plus 1. Okay. And then this is as simplified as that expression there is going to get, and then we want to evaluate the limit. And the limit focuses on the n terms. We can see that the order of growth of the n and the n plus 1 is the same. So we take the coefficients in front of them, and what we're going to wind up getting is an answer of 3 times the absolute value of x. From here, we are going to force convergence by saying that 3 times the absolute value of x must be less than 1 in order to have convergence, which means the absolute value of x must be less than 1/3. And there we have our radius of convergence, or if you wanted to write this out as a center and a radius of convergence, we can see that in this case r is equal to 1/3, thus satisfying the request of part A of this problem. The point breakdown for this on the AP test is you get your first point for setting up the ratio. So the n plus 1th term to the divided by the nth term gives you your first point. Your second point comes from computing the limit of the ratio. So after we've cleaned it up and we've evaluated the limit, this gives us the second point for the AP test. And then the third point comes from recognizing that the radius is 1/3. All right, and that is part A. Moving on to part B. Part B says write the first 4 non-zero terms of the Maclaurin series for f prime. the derivative of f. Express f prime as a rational function for the absolute value of x is less than r. So I'm going to go ahead and write f of x, and from there we can find f prime of x. Now, they've given us the first three terms of f of x, but the fourth term they didn't provide for us. We're going to need to consult the general rule to determine the fourth term. If I let n be 4, we have negative 3 to the third power, which is going to be negative 27. And then I said n was 4, so there's our fourth term plus dot dot dot. If we want to include the general term in there to be more mathematically precise and clean, that would definitely help out in being better mathematicians. Okay, we've got the f of x, and our goal was to find f prime of x. So this is a matter of early calculus AB material. Take the derivative of this expression. The derivative of x is 1. Derivative of 3 halves x squared is going to be 3x. Derivative of 3x cubed is 9x squared minus 27x to the third plus dot dot dot. There's the first four terms. I'm not going to show the derivative of the general term because they only ask for the first four non-zero terms, which we have there. It might be worth noting that there's a pattern that exists here. And that's going to help us answer the second part of the question, which is to write this as a rational function. What we have is a pattern that we should recognize as one of the ones that I asked you to memorize in class. Rewritten with the negatives inside the parentheses, we have something that is far more familiar. This is the power series expansion, and this can be rewritten as 1 over 1 minus negative 3x. Or if we distribute that negative, 1 plus 1 over 3x. 1 over 1 plus 3x. The point breakdown on this is there are 3 points. The first 2 points comes from having the first 4 non-zero terms. So those first 4 non-zero terms is worth 2 points. And then recognizing it as a rational function by rewriting it as a power series gets us our third point for part B.
So in tasting, what we do is take a small amount right off the top. It doesn't take much. That's the warmest part right here. I'm going to invert the spoon. Cover all 9,000 taste bud. Aerate it. Warm it up. Driving up that top note, that cream, pure vanilla, sweeteners. That's a 10.
Moving on to part C. Write the first 4 non-zero terms of the Maclaurin series for e to the x. All right. That's one that we all have memorized. E to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial, and the series goes on. Write the first 4 non-zero terms in the Maclaurin series for e to the x. Excellent. Use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x is e to the x times f of x. So g of x is e to the x times f of x. Or alternatively written as polynomials, we write e to the x times the value that we, or the power series that we found for f of x. Actually, they provided us f of x, we didn't find it. Okay. So this is our g of x expression, and we want to distribute all of this through, and this is where thinking out loud might help us. In the end, we are doing like this really large process of distribution. If it was just two terms, you could say we're foiling, but we've got more than two terms here. So what I'm going to do is I'm going to think through this in the magnitude of degrees. So do I have any multiples that are of degree 0, i.e. a constant times a constant? And that's not the case. So now I'm going to move up to degree 1. So I have the 1 times x, not degree 1, not degree 1, not degree 1, etc. X times x, not degree 1, not degree 1, not degree 1. Okay, so we've got our first term for the first degree. To that, we're going to then add our second degree things. So 1 times x is now 1 times negative 3 halves x squared. Negative 3 halves x squared. Nope. X times x, that's a second degree function. So x times x is x squared. And then nope. So now we've got all the second degree pieces put together. And then our third degree pieces, that is not third degree, and that is not third degree, but that is 1 times 3x cubed. And to that we're going to then, no. Okay, then we go x. X times x is not, x times this is a third degree. So what we have is plus negative 3 halves x cubed, fourth degree, fifth degree, sixth. And then x squared over 2 factorial times x, that is also a third degree. So plus x to the third over 2 factorial, which I'll just write as 2. Fourth degree, fifth degree. And on down. Third times first gives me a fourth degree, and they only want us to go to the third degree, so we're done. Everything else is going to be bigger than third degree. So these were our first degree pieces, these were our second degree pieces, these were our third degree pieces, and that's all we need. If we were to clean this up, negative 3 halves plus 1 is going to be negative 1 half. And then if I were to clean this up, I have 3 minus 1.5 would be 1.5, plus 0.5 would be 2. So 2x cubed. And there's the Taylor polynomial for g of x, the third degree Taylor polynomial. Okay. Technically, g of x includes all of the terms that we haven't included. So including those ellipses is useful. We could say g of x is approximated by the third degree Taylor polynomial, which we found to be those first 3 terms. Okay, this is worth 3 points. The first point comes from remembering the first 4 terms of e to the x. And this is kind of nice because we're at part C and there's still a very basic level question to get you a point. So don't give up on part A and B if you get lost. Sometimes part C you can still get a point. Okay. And then the last 2 points comes from the Taylor polynomial. And so I've shown the work through here, and then getting this Taylor polynomial down here gives us the last 2 points of the problem. All right, be sure to comment, like, subscribe, and have a good day.